Refraction through prism. The principal section of a prism is a triangle. Now, how light travels from air through the prism made of glass back to the air, we are going to learn today. During refraction, we will consider the triangular section, the principal section of a prism, the triangular section ABC. So, light will travel and gets refracted at AB. When it enters the glass section of ABC, it gets refracted at AB, and then again it hits the second refracting surface, that is AC. So, these are the refracting surface, and where the refracting surface is making an angle, that is the angle of the prism. So, here angle A is the angle of the prism. In this principal section of a prism, OP is the incident ray which strikes the refracting surface AB, gets refracted. The refracted ray is PQ when it is entering from air to glass. Then again it hits the refracting surface AC, gets refracted as it is going from glass to air, and the emergent ray QR comes out. So, the whole path is shown by this red line with the arrows. Now, if the incident ray travelled undeviated, then it would have taken the path OL. That means it is taking this path OL, and because of the refraction, twice it gets refracted, it is taking this path MR. So, the deviation, look at the deviation, OL is deviated to MR. So, this particular angle is the angle of deviation between OL and MR. Now, the angles. We are going to find out the angle of deviation, that is delta. For that, we have dropped two normal, Pn and Qn meeting at N. So, the angle of incidence between the incident ray and the normal angle I1, we have denoted by I1. The angle of refraction between the refracted ray and the normal R1. When it strikes, when the refracted ray strikes the second refracting surface, the angle we get is R2, and the emergent ray making an angle I2 with the normal. Here, the first deviation, if the incident ray would have passed undeviated, it would have taken the straight path OL. It got deviated, and we denote the angle by delta 1. Then, this we are denoting by delta 2. The second deviation we are denoting by delta 2. Therefore, delta, the final deviation or the angle of deviation, is equals to delta 1 plus delta 2. In this triangle MPQ, this is the external angle. So, delta is equals to delta 1 plus delta 2, sum of the two interior angles. So, we get delta is equals to delta 1 plus delta 2. Exterior angle is equals to sum of the interior opposite angle of the triangle MPQ. Next we get I1 is equals to delta 1 plus R1 because they are vertically opposite to each other. Vertically opposite angles are equal. So I1 equals to delta 1 plus delta 2. From there we get delta 1 is equals to I1 minus R1. Similarly, from this side we get I2 equals to delta 2 plus R2, and therefore delta 2 is equals to I2 minus R2. Therefore, from this equation, if we substitute the value of delta 1 and delta 2, we get delta is equals to delta 1 plus delta 2 is equals to I1 minus R1 plus I2 minus R2, that is I1 plus I2 within bracket. If we take subtraction sign outside, we get R1 plus R2. So we get the first relation, delta is equals to I1 plus I2 minus R1 plus R2 within bracket. Next, in this triangular section of prism, we have a quadrilateral A, P, N, Q. In this quadrilateral, angle P and angle Q makes 180 degree because both are 90. Definitely then angle A and PNQ will make 180 because sum of all the angles of a quadrilateral is 360. Therefore, angle A plus angle PNQ is 180. In quadrilateral APNQ, angle P plus angle Q, 90 plus 90, 180 degree. Angle PNQ and angle PAQ, when we are adding, we are getting 180 because all the angles makes 360 degree of a quadrilateral. Now in this particular triangle PNQ, angle R1, angle R2 and angle PNQ makes 180 degree because this is a triangle. Therefore, angle PNQ is equals to 180 minus R1 plus R2. So, from equation 1, we can write in this place, if we substitute the value of angle PNQ, we get angle PAQ plus 180 minus R1 plus R2 equals to 180. From there, 180 gets cancelled and we get PAQ, which is the angle of the prism A, is equals to R1 plus R2. When we use the second relation in the first relation, we get R1 plus R2 equals to A. So substituting the value, we get the sum of the angle of incidence plus angle of emergence is equals to angle of prism plus angle of deviation. From the equation, we can find out the factors affecting the angle of deviation. I1 plus I2 equals to angle of the prism A plus angle of deviation. From here we get the factors. The first factor, angle of the prism A. With the increase of the angle of the prism, we found that angle of deviation also increases. Next factor, material of the prism or the refractive index. Higher the refractive index, more is the angle of deviation. Third factor, color or the wavelength. Angle of deviation decreases with the increase of wavelength of light. Now violet light deviates the most, whereas red deviates the least. The fourth factor is the angle of incidence. This is I delta curve. This curve we get from the experiment which is done by the spectrometer. When we increase the angle of incidence, at the beginning angle of deviation decreases to a certain point, but then with the increase of angle of incidence it increases. So at this point we get minimum deviation. At this point we find from the experiment I1 is equals to I2, that is angle of incidence is equals to angle of emergence, and the refracted ray becomes parallel to the base of the prism. Now this particular relation for minimum deviation, if we utilize in the previous relation, I1 plus I2 is equals to A plus delta. So if I1 plus I2, I1 and I2 is equal, and let that be equals to I. So I plus I becomes 2I is equals to A plus minimum deviation. Minimum deviation becomes 2I minus A.